NEC 210.8A1 requires ground fault circuit interrupter or GFCI protection for electrical outlets in wet or damp locations. NEC 406.8 requires GFCI protection for immersion heaters. Some argue that because the immersion heaters are located in a wet environment, specifically NEC 406.8 requires GFCI protection for immersion heaters because GFCIs provide added protection against electrical shock and fire in case of a ground fault. Others argue that NEC 210.8A applies to electrical outlets, not to hardwired equipment, and NEC 406.8 applies to immersion heaters that are plugged into an outlet, not to hardwired heaters, as hardwired equipment in wet environments is often not GFCI protected. The heater manufacturer recommends GFCI protection for liability purposes because while not explicitly required by code for hardwired equipment, GFCI protection provides an added level of safety. The NEC code specifically requires GFCI protection for immersion heaters that are plugged into an outlet. However, there is no clear requirement for GFCI protection of hardwired immersion heaters. The decision of whether to provide GFCI protection for hardwired immersion heaters is a matter of safety and risk management. If there is a concern about potential electrical shock or fire hazards, it is recommended to install GFCI protection for hardwired immersion heaters and other electrical equipment. This will provide an added layer of safety and reduce the risk of accidents. When considering GFCI protection, it's important to understand what a ground fault is. A ground fault occurs when electricity deviates from its intended path and flows to the ground through an unintended conductor, such as a person. This can happen if the insulation on a wire is damaged or if water comes into contact with electrical components. GFCIs are designed to detect these ground faults and quickly interrupt the flow of electricity, preventing serious injury or death. There are different classes of GFCIs, each designed to trip at a specific level of current leakage. Class A GFCIs, which are commonly used in residential and commercial settings, trip when they detect a ground fault of 6 mA or more. This rapid response time is crucial for preventing electrical shock. In industrial environments, such as the plating area, the presence of water and conductive materials increases the risk of ground faults. Even small amounts of moisture can create a path for electricity to flow to ground. This is why GFCI protection is particularly important in these settings. The NEC, or National Electrical Code, is a set of standards for safe electrical installations. It's updated every 3 years and provides detailed requirements for various types of electrical equipment and systems. While the NEC doesn't explicitly require GFCI protection for all hardwired equipment in wet environments, it does mandate it for certain applications such as outlets in bathrooms and kitchens. The code also allows for the use of GFCI protection as a means of providing additional safety. When evaluating the need for GFCI protection, it's important to consider the specific characteristics of the equipment and the environment in which it's used. Factors to consider include the voltage and current levels of the equipment, the presence of water or other conductive materials, and the potential for human contact with the equipment. It's also important to consult with qualified electrical professionals who can assess the risks and recommend appropriate safety measures. In addition to GFCI protection, there are other safety measures that can be taken to reduce the risk of electrical shock. These include using properly insulated wiring, grounding electrical equipment, and providing regular training to employees on electrical safety procedures. It's also important to implement a lockout/tagout program to ensure that equipment is de-energized before any maintenance or repair work is performed. Lockout/tagout procedures involve disconnecting the equipment from its power source and attaching a lock and tag to the disconnect switch to prevent it from being accidentally re-energized. Regular inspections of electrical equipment and systems can help identify potential hazards before they cause accidents. These inspections should be performed by qualified electrical professionals who are familiar with the NEC and other applicable standards. The inspections should include a visual examination of wiring, connections, and equipment enclosures, as well as electrical testing to verify proper grounding and insulation resistance. When selecting GFCI devices, it's important to choose products that are listed by a recognized testing laboratory, such as Underwriters Laboratories or all. These listings indicate that the products have been tested and meet applicable safety standards. It's also important to select GFCIs that are appropriate for the specific application. For example, some GFCIs are designed for use in wet locations and are protected against moisture and corrosion. The installation of GFCI devices should be performed by qualified electrical professionals in accordance with the NEC and manufacturer's instructions. It's important to ensure that the GFCIs are properly wired and grounded and that they are tested after installation to verify that they are functioning correctly. Regular testing of GFCI devices is also recommended to ensure that they continue to provide protection over time. GFCI should be tested monthly by pressing the test button on the device. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In some cases, it may be necessary to use other types of protective devices in addition to GFCIs. For example, equipment that is particularly sensitive to voltage fluctuations may require surge protection. Surge protection devices, or SPDs, are designed to protect equipment from damage caused by voltage spikes or surges. SPD are commonly used to protect computers, electronic equipment, and other sensitive devices. Another type of protective device is an arc fault circuit interrupter, or SI. SIs are designed to detect arc faults, which are dangerous electrical conditions that can cause fires. Arc faults occur when electricity jumps between two conductors, creating a high-temperature arc. SIs are required in many residential circuits and can also be used in commercial and industrial settings. When evaluating the need for electrical safety measures, it's important to consider the potential costs and benefits of each option. GFCI protection can be relatively inexpensive to install, but it can provide significant protection against electrical shock. Other safety measures, such as surge protection and arc fault protection, may be more expensive, but they can protect equipment from damage and prevent fires. It's also important to consider the potential costs of not implementing adequate safety measures. Electrical accidents can result in serious injuries, property damage, and even death. The costs associated with these accidents can be significant, including medical expenses, lost productivity, and legal fees. In addition to the direct costs of electrical accidents, there are also indirect costs such as damage to reputation and loss of customer confidence. Companies that have a reputation for safety are more likely to attract and retain customers and employees. Implementing a comprehensive electrical safety program can help companies protect their employees, customers, and assets. This program should include regular training, inspections, and maintenance, as well as the use of appropriate protective devices. The program should also be documented and regularly reviewed to ensure that it remains effective. Electrical safety is an ongoing process that requires constant vigilance. By staying informed about the latest safety standards and technologies and by implementing a comprehensive electrical safety program, companies can reduce the risk of electrical accidents and create a safer work environment. There are numerous resources available to help companies develop and implement electrical safety programs. These resources include the NEC, the Occupational Safety and Health Administration, or OSHA, and various industry associations. OSHA provides guidance and regulations on workplace safety, including electrical safety. The agency also offers training programs and resources to help companies comply with its regulations. Industry associations such as the National Fire Protection Association, or NFPA, also provide valuable resources on electrical safety. The NFPA publishes the NEC and other safety standards and offers training programs and certifications for electrical professionals. When working with electricity, it's important to always follow safe work practices. These practices include wearing appropriate personal protective equipment, such as gloves and eye protection, and using insulated tools. It's also important to avoid working on energized equipment whenever possible. If it's necessary to work on energized equipment, it's important to follow lockout/tagout procedures and to use appropriate safety precautions. Electricity is a powerful force that can be dangerous if not handled properly. By following safe work practices and by implementing a comprehensive electrical safety program, companies can protect their employees, customers, and assets from the hazards of electricity. When dealing with immersion heaters specifically, the environment they operate in poses unique electrical hazards. Immersion heaters are often used in tanks or vessels containing liquids, which can create a pathway for electrical current to flow to ground. This risk is heightened if the liquid is conductive, such as water with dissolved salts or plating solutions. The presence of moisture and conductive materials near electrical equipment increases the likelihood of ground faults and electrical shock. Immersion heaters themselves can also be a source of electrical hazards. If the heating element inside the heater develops a fault, it can energize the surrounding liquid or the metal tank in which the heater is installed. This can create a dangerous situation for anyone who comes into contact with the liquid or the tank. Therefore, careful consideration of grounding and bonding is crucial for immersion heater installations. Grounding provides a low-resistance path for fault current to flow back to the source, allowing the overcurrent protection device, such as a circuit breaker, to trip and energize the circuit. Bonding connects all metal parts of the electrical system together to create an equipotential plane, which minimizes the voltage difference between different metal surfaces. This reduces the risk of electrical shock if someone comes into contact with two different metal parts at the same time. Regular inspection and testing of immersion heaters are essential for maintaining electrical safety. The heater element should be visually inspected for signs of damage, such as cracks, corrosion, or bulging. The electrical connections should be checked for tightness and corrosion. The insulation resistance of the heater should be tested to ensure that it is within acceptable limits. The grounding and bonding connections should be verified to ensure that they are intact and effective. If any problems are found during the inspection, the heater should be repaired or replaced immediately. In addition to regular inspection and testing, it's important to follow proper maintenance procedures for immersion heaters. The heater should be cleaned regularly to remove any buildup of scale or other deposits. A heating element should be replaced if it becomes damaged or worn. The electrical connections should be tightened if they become loose. The tank or vessel in which the heater is installed should be inspected for corrosion and leaks. By following these maintenance procedures, the lifespan of the immersion heater can be extended and the risk of electrical hazards can be minimized. When selecting immersion heaters, it's important to choose heaters that are designed for the specific application. The heater should be sized appropriately for the size of the tank or vessel and the type of liquid being heated. The heater should be made of materials that are compatible with the liquid being heated. The heater should be equipped with appropriate safety features, such as over-temperature protection and ground fault protection. Over-temperature protection is designed to prevent the heater from overheating if the liquid level drops too low or if the heater malfunctions. This can help prevent fires and damage to the equipment. Ground fault protection, as discussed earlier, is designed to protect against electrical shock in the event of a ground fault. In addition to the safety features of the heater itself, it's important to consider the safety features of the electrical system that supplies power to the heater. The electrical system should be properly grounded and bonded. The circuit breaker or fuse that protects the heater circuit should be sized appropriately. The wiring should be sized to carry the load of the heater without overheating. The electrical system should be inspected regularly to ensure that it is in good condition. Proper training is essential for anyone who works with immersion heaters. Workers should be trained on the proper operation of the heaters, the potential electrical hazards, and the safety procedures to follow. Workers should be trained on how to inspect and maintain the heaters. Workers should be trained on how to respond to electrical emergencies. By providing proper training, employers can help ensure that workers are aware of the risks and know how to protect themselves. The manufacturer's recommendations should always be followed when installing, operating, and maintaining immersion heaters. The manufacturer's recommendations provide valuable information on the proper use of the equipment and can help prevent accidents. The manufacturer's recommendations should be kept in a safe place and should be readily available to anyone who works with the heaters. In conclusion, electrical safety is paramount when dealing with immersion heaters. The combination of electricity, water, and conductive materials creates a potentially hazardous environment. By following the recommendations outlined above, including GFCI protection where appropriate, proper grounding and bonding, regular inspection and testing, proper maintenance, selection of appropriate equipment, proper training, and adherence to manufacturers' recommendations, the risk of electrical accidents can be significantly reduced, creating a safer work environment for everyone.